This video is the third for the Precal functions test review, and it starts with problem number 4 in homework 2.6. So the problem statement is as follows. A wire 18 meters long is to be cut into two pieces. One piece will be shaped as a square, and the other piece will be shaped as a circle. See figure. Answer the following questions. Express the total area enclosed by the pieces of wire as a function of the length x of a side of the square. Okay, so the square is shown here, and each side is going to be x. So this section of the wire labeled 4x, that's going to be cut off and formed into a square. So the rest of the wire is going to be the total length, 18 meters, minus the 4x that we took out to make the square. So the area of a square is usually given as area equals side length squared. Now the area of a circle is pi times the radius squared. So this is pretty easy for the square. The side length of the square is going to be x, so that's going to be area equals x squared for the square portion of this. Okay, now we know that the circumference of a circle is 2 pi times the radius, and the circumference of this circle made out of wire is going to be 18 minus 4x. So to use this formula for the area of a circle, we need to get radius in terms of x. Now I'm going to take a shortcut because I realize that I've got a 2 here, 18 is evenly divisible by 2, and 4 is evenly divisible by 2. So I'm going to take this entire equation and divide it by 2. So that will give me pi times the radius equals 9 minus 2x. Now I can divide both sides by pi, and I get radius equals 9 minus 2x all divided by pi. So the circle portion of this is going to be pi times the radius squared, and I now have an expression for radius as a function of x, which is 9 minus 2x all over pi. So if I square that, I'm going to get pi times 9 minus 2x squared all over pi squared. So I can cancel one pi with one of these down here, and I can expand this binomial. The easy way, square the first term, multiply the two terms together, so that would give me negative 18x. I double that to negative 36x, and square the last term, so negative 2x squared is positive 4x squared, then all over pi. It seems really complicated, but logically it's not. It's just area of a circle. So our final function is going to be a as a function of x equals x squared, so that's the area of the square portion, plus this big fraction, which is the area of the circle portion. So it's minus 36x plus 4x squared all over pi. We'll go check that in the book. So x squared, shift plus, then we need a fraction. So 81 minus 36x, shift plus 4x squared, break out of the exponent, go down to the denominator, and put in pi, and we'll check that answer, and the book says fantastic. Now, the domain. Again, the book is not actually asking about the domain of this mathematical function. It's asking what's the domain considering this hypothetical physical situation. So if we think about it, I have to have a square x has to be something a little bit more than 0. So I'm going to say it's an open interval starting just above 0. And then if I do the minimum for a square, x is going to just be a tiny bit above 0, and then most of the area and the wire is going to be involved in the circle. If I max out the square, okay, 18 divided by 4 would be 4.5. But if I do exactly 4.5 for each side of the square, I don't have anything to leave anything left over to make a circle out of. So I'm going to say it's from just above 0, where we're maxing out the circle, to just below 4.5 meters, where we're maxing out the square. So we'll go try that in the book. So I put in the template. So 0, just above 0, to not quite 4.5 meters. And check that answer. And the book liked that. So it says graph area as a function of x. For what value of x is the area the smallest? So we'll go to the calculator again. Document, or doc for documents window, 4 for insert a new problem, or for insert, 1 for a new problem, and 2 for a graph. So our function is x squared plus control divide to get a fraction, 81 minus 36x plus 4x squared, all divided by pi, and pi on the TI Inspire lives in the pi palette. There's pi. Now, we don't see anything. Not a problem, we just don't have the right window. So I'm going to go Menu, 4 for window zoom, and I want to set my own window. So my actual domain is from just above 0 to just below 4.5. So we'll use that. We'll put a tick mark every one. So I'm going to go like -10 to, let's say, 50 meters squared, and put a tick mark every 5. I hit enter, and it's a pretty good window. I do, in fact, have a gentle curve here that does have a minimum. So I'm going to go Menu, 6 for Analyze Graph, 2 for Minimum, and the calculator asks me for the lower bound and upper bound again, and hopefully that's enough decimal points. So we'll go back to the book, round to 2 decimal places, so 2.52, 2.52, check answer, it liked that, and that would send us on to the next question, so I'm going to end the video now.